Hello everyone, Elon Musk here, and today there is information to share that could upend not only our understanding of Tri-Eye Atlas, but of what is even possible in space. What appeared in the engineers' reports this morning makes it necessary to reconsider everything known about interstellar objects. Yesterday, at 3:47 Moscow time, a Deep Space Network tracking station recorded an anomaly in Tri-Eye Atlas's motion. An object that should have continued along a precisely calculated hyperbolic trajectory suddenly shifted direction by 0.3 degrees. That may seem minor, but on a cosmic scale it implies a deviation of millions of kilometers from the original course. Here is why this matters. Comets and asteroids move according to the laws of celestial mechanics, studied for 3 centuries. Their paths are governed by the gravitational fields of the Sun and planets. Minor adjustments are possible due to outgassing jets under heating, but what is being observed with Tri-Eye Atlas exceeds reasonable bounds. Immediate contact was made with the JPL team, European colleagues at ESA, and even Russian specialists. All confirmed, the trajectory change of Tri-Eye Atlas is not explained by known physical processes. The reactive effect from sublimating ice simply cannot produce such a directed acceleration. More troubling still, it is not a one-off. Analysis of archival data shows similar, albeit subtler, course corrections occurred at least 3 times over the past 2 weeks. The object seems to be trimming its path, drawing closer to the Sun. The chief orbital mechanics engineer ran detailed calculations. If this trend holds, Tri-Eye Atlas will reach perihelion not on October 29th as planned, but 3 days earlier. Critically, its path now passes significantly closer to Mars's orbit. Initial estimates indicated the object would pass 28 million kilometers from the red planet. That distance has now shrunk to 18 million kilometers. If corrections continue, a scenario emerges that no one considered a realistic possibility. Let's break this down. What could make an interstellar object change trajectory in this way? First hypothesis: heterogeneous internal structure. Perhaps Tri-Eye Atlas's nucleus contains cavities or channels producing directed gas jets that act like natural thrusters. Second possibility: materials with unusual physical properties within the object. Other star systems might host minerals or chemical compounds that respond to solar radiation in ways unknown among substances in our solar system. Third, the most intriguing hypothesis concerns a potentially artificial origin of the observed effects. This is not about little green men, but a technologically advanced civilization could have created an object capable of navigation in interstellar space. Sounds like science fiction. Perhaps. But remember, reusable rockets once seemed fantastical. Autonomous cars were impossible. Satellite internet was deemed uneconomical. Technology grows exponentially, and what is implausible today may be commonplace tomorrow. Here is the engineering worry. Tri-Eye Atlas's course corrections are not random. Data analysis shows a pattern. Direction changes always optimize the trajectory relative to planetary gravitational fields. It resembles gravity assists used to accelerate spacecraft, but our probes perform such maneuvers along pre-computed paths. Tri-Eye Atlas appears to be adjusting in real time, adapting to changing conditions. An emergency video conference convened with leading celestial mechanics experts at MIT, Caltech, and Stanford. A natural explanation for the phenomena was sought. The result is discouraging. No existing model fully accounts for Tri-Eye Atlas's behavior. Professor Thomas Yildiz of MIT proposed the smart materials hypothesis, substances capable of changing properties in response to external stimuli. Possibly Tri-Atlas's surface includes compounds that alter reflectivity or absorptivity of sunlight depending on temperature. Such materials could create directed radiation pressure to tweak trajectory. Terrestrial analogs are solar cells, but governed not by commands from Earth, rather by the material's inherent properties. Dr. Anna Cortez of Caltech advanced an even more radical idea. What if Tri-Atlas is not monolithic, but an aggregate of many smaller fragments bound by weak forces? When heated by sunlight, the structure might reconfigure, changing aerodynamic properties and producing a controlled flight effect. Yet these hypotheses remain speculative, without detailed observations. A critical problem looms. In 2 weeks, solar conjunction will make ground-based observations of Tri-Atlas impossible. Control over the situation will be lost precisely as the object reaches peak activity. Therefore, extraordinary measures are being taken. SpaceX is reallocating resources to bolster Martian observation programs. Orbital spacecraft software is being upgraded to track fast-moving objects with greater precision. Additionally, preparations have been ordered for an emergency launch of a scientific satellite to monitor Tri-Atlas. Normally, such a mission takes months of prep, but bureaucratic stages will be burned down. A ready Starlink platform can be rapidly refitted for science. The satellite will carry high-precision spectrometers and cameras capable of tracking Tri-Atlas even during solar conjunction. It will be placed into a highly elliptical orbit to observe from maximal distance above Earth's atmosphere. Time works against us. Every day of delay means lost data about the most enigmatic object ever to visit our solar system. If the worst fears are confirmed, humanity may face a situation for which it is wholly unprepared. Imagine an object from another star system showing signs of controlled flight approaching the inner planets, whether due to unknown natural processes or evidence of extraterrestrial technology. The consequences would be revolutionary. Another concern. After the corrections, Tri-Atlas's path crosses regions of heightened space debris concentration. Interplanetary space between Mars and Jupiter contains millions of asteroids of varying sizes. If Tri-Atlas truly navigates, it must account for such obstacles. But if course changes are random or based on incomplete information, the object could collide with a sizable asteroid. Such an impact would fragment Tri-Atlas into numerous shards, each continuing on its own trajectory. Some fragments could threaten the inner planets, including Earth. That is why the situation is deemed critical. Maximum information must be gathered before Tri-Atlas disappears behind the Sun. Every observation, every spectrum, every measurement might be decisive in understanding the object's nature. There is a positive angle. If Tri-Atlas indeed demonstrates unknown principles of space navigation, studying them could spark a revolution in space technology. Imagine spacecraft able to correct trajectories without fuel, leveraging only interactions with solar radiation. Such technologies would transform interplanetary and interstellar flight. Missions to the outer planets would be cheaper and more efficient. Journeys to nearby stars would move from fiction to practical astronautics. At Tesla, there is continual study of new energy efficiency principles. Each innovation in energy flow management finds application in vehicles. Similarly, Tri-Atlas's navigation principles might benefit not only spaceflight, but terrestrial transport systems. Imagine autonomous cars optimizing routes in real time, accounting not only for traffic, but also wind, air temperature, humidity. Systems extracting extra energy from the environment to extend range. First, however, understanding what is happening with Tri-Atlas is required. That demands international cooperation at a level rarely seen in peacetime. Contact has already been made, with heads of the world's major space agencies proposing a united monitoring group. NASA is allocating Hubble time to obtain detailed images. ESA is providing computing power to process large volumes of observational data. Roscosmos is sharing information from Russian ground observatories. Even China's space agency, despite not always simple relations, has agreed to provide data from its telescopes. This shows how seriously the scientific community regards the situation. And that is right. Whatever Tri-Atlas is, an unusual natural object or something more exotic, its study can benefit all humanity. In science, major breakthroughs often arise from anomalous phenomena. Radioactivity emerged from investigating unexplained uranium glow. X-rays were discovered by chance. While working with cathode tubes, penicillin was found thanks to a contaminated bacterial culture. Tri-Atlas could be such a serendipitous discovery that opens new domains of science and technology if enough data are gathered to grasp the processes at play. Another key point: Tri-Atlas's trajectory changes are not uniform in time. Data show corrections occur with a specific periodicity, about every 73 hours. That is too regular for random processes. Moreover, each correction's magnitude is tuned to optimize the onward path. These are not chaotic gas jets, but precise maneuvers accounting for planetary gravity fields many millions of kilometers ahead. Such foresight implies either an incredibly sophisticated internal structure capable of long-term planning or external control. Because no signals directed to Tri-Atlas have been detected, an autonomous navigation system is the likely inference. Technologies like this sit at the forefront of modern robotics. At Tesla, vehicles already predict other actors' behavior and plan routes several turns ahead, but Tri-Atlas demonstrates complexity orders of magnitude higher. The object plans its trajectory considering gravitational fields that will influence it months ahead. That requires accurate knowledge of planetary masses and positions, the ability to forecast their motion, and skill in computing optimal maneuvers to achieve specific goals. What goals might Tri-Atlas pursue? If natural, the goal is survival, optimizing the path to minimize destructive solar and gravitational effects. If artificial, the goals could be very different. Perhaps Tri-Atlas aims for close planetary flybys for detailed study, or for collecting material samples from various solar system regions, or for deploying instruments or devices at strategic points. Alarmism is not the intent, but entrepreneurs and engineers consider all scenarios, including worst cases. One concerns potential impacts on near-Earth space. If the object truly navigates precisely, it could adjust to pass-through zones hosting our satellites. Even without direct impact, a massive object's gravity could perturb spacecraft orbits. The Starlink constellation includes over 5,000 satellites in low Earth orbit, GPS, communication systems, weather satellites. These are critical infrastructure. Any disruption would have catastrophic consequences. Therefore, all Starlink constellation backup control systems have been activated. Satellites are ready for emergency maneuvers if Tri-Atlas's path poses risks. Space monitoring is being enhanced. Each Starlink satellite has sensors to detect approaching objects. If necessary, this network can serve as an early warning system for space hazards. Back to the science. Tri-Atlas's trajectory changes coincide with changes in its physical characteristics. The object's brightness is increasing not only due to approaching the sun, but also due to coma structure changes. Spectral analysis shows the composition of emitted gases varies synchronously with course corrections. During maneuvers, diatomic carbon concentration increases several-fold. giving a more intense green hue. This may indicate that navigational maneuvers demand significant energy, leading to enhanced sublimation of certain nucleus substances, or the emitted material's composition is intentionally altered to produce the needed reactive effect. Either way, the object exhibits complexity far beyond any previously observed natural celestial body, forcing a revision of what is thought possible in nature. Now, information that until today was strictly classified. 3 days ago, SETI radio telescopes detected a faint radio signal whose preliminary source is Tri-Eye Atlas. The signal is extremely weak, at the threshold of instrument sensitivity, but its structure suggests an artificial origin. It is not the random noise typical of natural radio sources, but an organized sequence of pulses with a particular periodicity. Especially interesting, the radio signal's periodicity precisely matches the trajectory correction. Periodicity. Every 73 hours, Tri-Eye Atlas emits a series of radio pulses and then changes direction. It could be coincidence, but the odds are minuscule. A joint team from SETI, NSA, and top cryptographers is working on decryption. Results remain classified, but identified patterns indicate a high level of organization in the transmitted information. If the signal truly carries encoded information, it would be the first confirmed contact with extraterrestrial intelligence in human history. Even if it proves natural, the mere correlation between radio emission and navigational maneuvers would open new physics. Most impressive is that Tri-Eye Atlas showcases technologies decades ahead of human capabilities: autonomous interstellar navigation, efficient propellantless propulsion, ultra-long-range radio communications. If the operating principles can be understood, keys to a revolution in astronautics would be in hand. Interstellar travel would move from fiction to practical planning. Exoplanet colonization could become reality for the next generation. Therefore, studying Tri-Eye Atlas is the top priority for civilization. Every minute of accessible time must be used to gather information. Each observation may be key to understanding its nature. A call goes out to everyone who shares the vision of humanity among the stars. Support these efforts, subscribe to updates, share information, help draw public attention to the issue. Tri-Eye Atlas may be a messenger from another world, bearing knowledge that could change human history. If its message is correctly interpreted, that requires united efforts from the planet's scientific community. The next 2 weeks will be critical. Little time remains before solar conjunction, after which observation options will be severely limited. Every hour must be used to the fullest. Behind closed doors in government institutions, much has unfolded in recent days. Yesterday, a call came from the Pentagon. The Secretary of Defense personally requested a meeting to discuss national security issues related to Tri-Eye Atlas. Present were representatives from NASA, NSA, CIA, and other agencies whose names cannot be disclosed. The atmosphere was tense. Everyone understood we stand on the threshold of events that could fundamentally change humanity's future. General Michael Harrison, head of US Space Command, presented an analysis of potential threats. If Tri-Eye Atlas is indeed artificial, its presence in the solar system may mean Earth civilization is under extraterrestrial observation. Mr. Musk, he said, SpaceX technologies are the most advanced humanity possesses. If this object is a threat, we count on your help developing countermeasures. It was explained to the military that it is premature to treat Tri-Eye Atlas as a threat. So far, its behavior shows no hostile intent. On the contrary, course corrections optimize transit through the solar system with minimal planetary impact, but they insisted on contingency planning. Agreement was reached At SpaceX, preparation for varied scenarios is standard. Better to have a plan and not need it than be defenseless in a critical situation. Multiple projects are underway simultaneously. First, upgrading existing satellites for more detailed monitoring of Triae Atlas. Second, preparing a specialized probe for a close approach if needed. The third project is the most ambitious, designing a concept for an autonomous spacecraft capable of intercepting fast-moving objects. This requires fundamentally new navigation and propulsion technologies. At Neuralink, possibilities for brain-computer interfaces to control spacecraft in real time are being explored. If a pilot must make split-second decisions across millions of kilometers, traditional control methods will be insufficient. Imagine a pilot on Earth controlling a spacecraft near Mars by thought. Neuralink's interface would transmit commands at the speed of thought, compensating radio signal delays with predictive algorithms. These developments, however, require time, which is in critically short supply. Each day, Triae Atlas nears the Sun, reducing opportunities for study and interaction. Especially troubling, analysis of the latest course corrections shows the object is not merely optimizing its path through the solar system. It is moving toward a specific target in space between Earth's and Mars's orbits. Extrapolating the current trajectory with observed corrections, Triae Atlas should reach a point 15 million kilometers from Earth around December 15. That is 40 times closer than the Moon's orbit. At such a distance, the object's gravity could affect satellite orbits. Tidal effects might alter Earth's atmosphere and oceans, and that assumes Triae Atlas takes no additional actions. What if its goal is more than a simple Earth flyby? What if closer interaction with our planet is planned? Preparedness for any development is necessary, hence the decision to fast-track an interception mission. Starship, originally designed for Mars flights, will be modified to meet Triae Atlas. It will carry state-of-the-art scientific instruments and remote sensing systems. This will not be a purely scientific mission. On board, systems will be installed to influence Triae Atlas's trajectory, if required. Powerful lasers for localized surface heating, electromagnetic radiation generators, even small rockets for physical intervention. This sounds aggressive, but consider an unknown origin object approaching Earth with unclear intentions. The planet must be defendable if needed. Preferably, the scenario is peaceful contact. If Triae Atlas is truly a messenger of an extraterrestrial civilization, it would be the greatest event in human history, answering fundamental questions about our place in the universe. Yet preparation for less optimistic outcomes is also essential. In this context, plans for Mars colonization gain special importance. Should events with Triae Atlas go awry, humanity might need a backup planet. Therefore, preparations for the first crewed Mars flights are being accelerated, regardless of Triae Atlas's outcome. A self-sustaining colony on the Red Planet must be built as soon as possible. At the Boring Company, technologies are being developed for underground shelters to protect Martian colonists from radiation and extreme weather. These same technologies might prove useful on Earth should the Triae Atlas situation spiral out of control. Who knows? When Triae Atlas re-emerges from behind the Sun in December, its true nature may already be understood. By then, humanity may have answers to questions pondered for millennia. Are we alone in the universe? Do technologies exist that overcome interstellar distances? Triae Atlas may provide these answers, if we are ready to hear them. That requires not only scientific curiosity, but readiness for the consequences of such answers. Humanity stands at the threshold of a new era, an era when we are no longer alone in the universe. How we prepare for this encounter may decide the future of Earth civilization. There is faith that humanity is ready. Technologies capable of carrying us to the stars have been created. Science has advanced to the point of grasping nature's fundamental laws. Most importantly, curiosity and the drive for knowledge, our perennial engines, remain intact. Tri-Atlas is not a threat, it is an opportunity. An opportunity to take the next step in our development as an intelligent species, and there is confidence we will seize it.